Hello, all my wonderful YouTube subscribers, new viewers, whoever you may be. Welcome to my channel. My name's Todd, Ellensburg Amplifier Repair and Service here in Central Washington. I do have a full-time business here, repairing amplifiers, so that's what you'll see on my channel is different amplifier repairs and some important information that I feel I should get out to the repair world. Just to help make people's lives a little easier. As you can see here, I have a board on the table. This is a really common design of an amplifier output stage. I call this, me personally, I don't know if everyone else does, but I call this the S&I design. This is typical for the Korean boards like the Crescendos, the Pitbull, the 20K Pitbulls. This is the Bonce Apocalypse 20K output board, which again is the same design as a lot of other Korean boards, but I favor this particular board more than the others. And this is where I'm going to go over some of the details about this board. Some of these steps and processes that I take to repair boards. It'd be nice if I can get this all the way into the screen view here for you guys. Again, just to help make people's lives a little easier. I get a lot of questions on amplifier repairs, and I do my best to try to help explain those. But in a lot of instances, it's really hard to explain how to diagnose and repair something through text, email, messenger. It's hard to do that, so that's when I decide sometimes I just need to put a video out for you guys to go back through and figure out the best way for you to repair the board. So again, my most favorite design, well, my most favorite layout, a real common design. So this uses, let me grab my little pointer here. This uses the MIC 4452 drivers. This particular board has two output drive cards, which is super fantastic. I like that design. This uses two voltage regulators that's referenced to negative rail, which I absolutely, hands down to the companies that are using two regulators instead of one, to help spread that load a little bit better. I do like to see the two regulators personally, so that's a plus. This uses, what is this? Give me 2 seconds. I just need to verify something here real quick. I just started to check. So this board uses the 59 and 30 output transistors, and I call this board the wide board design. It's really wide, kind of just like the Crescendo 17K, the Pitbulls, so the typical bigger Korean Class D amps. And the reason why I like these wide boards is if you notice, the spacing of these 59 and 30s is a lot. There's a lot wider gap in between the 59 and 30s compared to an amp that uses the 24 and 40s, which are really close together. So this really does help just dissipate that heat out of these transistors that these produce during operation. And that's key to amplifiers, is keeping them cool. Electronics, again, and one of the #1 killers of electronics is heat. So getting that heat out is great. Thumbs up. So the 59 and 30, the MIC 4452 drivers, these cards use the IRS-2184 ICs here. Uses what, a 072 and a, what is the other one, a 311 Um, some cards, some of these output cards, they deface these ICs and some don't. So the 2184 is defaced here, but not the two op amps or op amp and comparator. I think that are the ones a comparator. Hold on, let me check. I don't rebuild these cards often, so it's not very often I have to rebuild one of these. I got to get my help in eyes because I'm blind. So yeah, that's what I thought. So it uses a comparator and a op amp. So the top IC here is a 211 and the bottom IC here is a 072. So just real common, what do they call those, jelly bean components? They're just a common component, which is great for serviceability of amplifiers. Anyone that does this as a business knows that the older an amp gets, the harder it is to get the parts for them because they quit. The manufacturers use parts that are just not, in my opinion, industry standards. Yes, like the day they ever start using MCUs or PICs or programmable chips in these, I may stop servicing them. Luckily, these are all straightforward still. So let me just double check everything. We're looking good. So values, resistance values. This is where diagnosing and troubleshooting these amps just comes in really absolutely handy to diagnose and troubleshoot these. Try to get this whole thing in view for you. So what I do, first thing I do on any of these Korean boards is I always check for output shorts. If the customer states the amplifier comes on but goes into protect, you know that most likely you have a shorted output section if you don't have a like a broken transformer winding going to your auxiliary power off the power supply side. 9 times out of 10 though, guys will pop the output section on these. And along most all these amps have about the same resistance values. So like for instance, this particular board, again this is the Bonce 20K. This is 16.6 kilo ohms from gate source. Why is that, you ask? Well, it's really simple if you understand how these work and are designed, but each transistor has a pull down resistor and there's a certain number of pull down resistors in parallel, and what happens with resistance when you put same value resistors in parallel. So that's what I'm looking for, is I'm looking for that 16K across every single gate source of the output section. Now, I've already fixed this board before I decided I really wanted to put a video on this. So, because there's issues on this that I wanted to point out on the video. So this initially had a 33 ohm short on this side in the output section, which I knew, transistor. So I had 33 ohms, but now I'm reading 16, of course, because like I said, I've already repaired this board. So you pull all the output transistors. The 59N30s, they're not cheap. They were a little hard to find. Pull them all out. I mean, just don't even mess around with it. Take them all out. Start from a bare board. It'll really, really help you. Unless you're just not good at soldering or desoldering these TO247 transistors. They can be a pain if you don't have the right equipment. So 16K, and I'm just going to drop across this backside here just to verify my 16K. It's actually 16.6. Oh man, hold on guys, I got a phone call. I'll be right back with you. All right, where was I? Sorry about that guys, I had a phone call. Customer had a pile of Stetson amps that he was wanting to get repaired, but yeah, I'll just leave it at that when it comes to Stetson. So where was I? I think I was talking about the resistance values. I was checking my 16K resistance values. Of course, 16. Let me make sure my meter doesn't shut off on me here. 16, 16, 16, 16. So I had a short over here, pulled out all the transistors, And I replaced the two MIC 4452 drivers here. And most times too, I will also have to replace the Zener diodes down here. I think these are 18-volt Zener diodes. I don't have things memorized. It's always bad to memorize things, in my opinion. Unless, of course, you're talking about pull-down resistance. Oh, I've got some text coming through. So once I get everything replaced, get the Zener diodes replaced, get the MIC 4452s replaced, and then I check the, I do believe these are snubber resistors. Can you see right here? This is a little 1/8 watt 10 ohm snubber resistor. This looks like an RC snubber here. This resistor and this capacitor. So these are 10 ohm resistors, and there's 4 of them, one for each corner of this board. And 9 times out of 10, when you pop an output section, these little 10 ohm resistors will read, well, not 10 ohms. Now they read 10 ohms because this one and this one is replaced. But sure enough, this 10 ohm resistor, let me see if I can get everything in view here. This 10 ohm resistor right here behind this rail capacitor was reading about 2,700 ohms. And this one over here was reading over 20K. And the other two back here are still reading 10 ohms, which is really odd. There's no physical damage to these resistors, but it's always good to check the value. So now it is 10 ohms, and this one is now 10 ohms. Perfect. So that's something that is usually overlooked on the repair of these amplifiers, are these snubber resistors. And I have caught myself a few times forgetting to check those snubber resistors. Again, there's 4 of them. And you also have snubbers here for each drive through this 1 kV capacitor, through this resistor, 21 ohms. So it's always best just to verify and double check all your resistance values, because you don't want your good work to go up in smoke when you fire these things up. And you'll see here taped here, so these are the JFETs, these are the J111s, these are the muting transistors that I have removed from 2 locations. One location is right here, and the other location is right here. One mutes one card, one mutes the other card. So to test boards like this outside of the primary power supply, the one that's in the amplifier, you have to remove the muting transistors to fire this up and test it with an external power supply. So that's the point I'm at right now, is hooking up power. Let me see if I can get a little wider shot here for you guys. Probably I'll get my scope leads in the way here. All right. So I've covered this before in other videos, or a video. I'm not sure how many videos I have on it, but I use a conglomerated mess of a power supply to test the output boards of these Korean amplifiers. Just screws here, speaker terminal screws. These are what, are these these are M5s. M5 screws, so you need a positive rail, you need a negative rail, and I like to put a COM in here just in case. So negative rail. So this is one of the few things I do have memorized, because these are all the same. Negative rail, positive rail, common, just like that. Again, we have positive rail, negative rail, common, AC. This is this is the AC for the plus minus 12 volt regulators over here. Which again, it goes back to if you don't know your board or you're not used to working on these, just follow the traces. This trace goes all the way across over to the capacitors before the 10 ohm resistors that supply the voltage regulators. So of course it goes through their diodes, respective diodes. And then one last lead is a lead that is referenced to negative rail. I call that my negative rail reference. It's written on the wire right here, reference, negative rail, AC. So as long as you get your negative rail referenced at your 7812 voltage regulators over here that are in parallel, off camera again, of course. Let me move my coffee. Let me see if I can show you. My table's just a little too small for these big boards. So you can kind of still see the terminals that I have set up here. The negative rail reference terminal lead here. You can follow that trace, goes right across the board, goes over and hits this inductor right here. And then it goes to your voltage regulators here that are referenced to negative rail. Sometimes when you pop the MIC 4452s, one or more of these, you will have a large enough short to ground that this inductor right here will be open. So always just verify the resistance value of that inductor. If this inductor's open or has been blown open, you'll see a little hole right in it. I replace the voltage regulators. That just tells me that a really good surge current went through it. I just replace the regulators, because if anything happens to these regulators, you could lose the output section. Just keep that in mind. So yeah, so I end up replacing those, and then that's pretty much what I do to fire these up. I mean, I don't have my scope started yet today, because I don't need a scope to diagnose and repair to this point. But from here, the next step is to verify that you have a low side gate drive. I mean, from your cards, which you'll find over here on the pads when you fire this up. And then I also use the thermal imager, because if you have any shorts, over here off your drivers or anything shorted to negative rail, you will pop this capacitor. It'll heat up, and I mean just instantly heat up, and it'll get hot, and you'll blow the top right off this thing. So that's my next step, is to fire up my thermal imager to watch these capacitors right here, these two capacitors. And then if I find that these are what I call stable, the regulators will heat up just as they should. They will heat up a little bit. But as long as these capacitors don't start glowing red hot on the thermal imager, then I know I don't have any shorts here, and then I can continue with checking with the scope. My power supply over here, off to the side, right here, guys, produces about 68 volts, positive and negative rail. So I'm using about 68 volts roughly to do this testing, and I will see on the scope, I'll see the switching. Well, when I put the output transistors back in, I'll see the switching, not a full sine wave. So, because in this kind of setup here, I don't have the appropriate feedback. But you will see kind of a half sine wave on your scope, or you'll see the beginnings of a square wave, depending on what side of the inductors you're checking your signals. So on this particular amp here, I would be checking probably my signals. I'll be checking right off of the snubber resistors here. I do believe. Let me just verify real quick. Yep. Oh, that was a capacitor. My bad. Sorry. Yeah. So this resistor, these two 220, what is that? 2.2K. Red. 2.2K resistors here. You'll see that sine wave. Nope. Not a sine wave, not a full sine wave. Because these are after the inductors. So that's how I check it. But that was the biggest key, is I wanted to point out that you want to verify these 4 resistors here. Let me see if I can point in the right direction here. Yep, this resistor, and then of course you're going to have identical ones on the other side. Make sure there's those still 10 ohms. Make sure your pull down values are consistent through each section of the amplifier. There's, as you can see, there's 4 sections here. 1, 2, 3, 4. So you want to make sure that you're reading 16K at each one of these. And then if you're reading 16K, you're good to go ahead and power up the board with low voltage to check to make sure you have drive from your drive card and to make sure your drivers are good. You'll see a low side square wave on the board, and if you see your low side square wave, you're good to go. Put your transistors in, fire it back up with your low voltage again without the muting transistors installed, and you'll see that switching. It'll attempt to start. It won't fully start, but it will attempt, and that's all you're after. Because if there's any issues with these when you first powered up, even with low voltage, if there's a problem anywhere, it'll heat up instantly. Your transistors will heat up. You're going to have 4452s heat up. You're going to have resistors heat up. You're going to have something heat up. And as long as your thermal imager shows everything's fine and you're showing the start of a drive, slap her together, put her back in into the main board, fire it up, load test it, be good to go. Anything else that I cover on these? Very few times do I ever have issues in the preamp. Very few. Sometimes you're going to have problems in your Zener diodes over here. Are they using? There should be a feedback. Sometimes, depending on the short, it can damage the feedback circuit. I think the feedback goes through the 4558 or one side of the TL074. I can't remember. I'd have to look at the print. So you'll find your feedback over there. 9 times out of 10, though, depending on how it fails, I don't have issues over here. Any other areas of interest? If you find the amplifier going into protect after you rebuild everything, then you got to go back through and check your feedback circuit realistically. And then there's some, what are these, A92s here. So some of this is all involved with your protection circuits, but most times there's hardly ever issues. So I don't want this video to go on long-winded, so if you guys have any questions, concerns, or comments, please leave them down below, and I will always get to you as soon as I can. Please like and subscribe if you want more of this content. Now my other phone's ringing. And from there, I'll catch you guys soon again. Thanks for watching.